Weight initialization is really about giving models the best chance to learn when training. And since many models rely on iteratively improving by looking at the mistakes they've made, we want them to start out making more informative mistakes, ones that are instructive and provide information about how exactly a model can improve. We found that this was not the case when we initialized with constant weight values, so it might make sense to take a totally different approach. Instead of setting everything to all zeros or all ones, what if we want to have all of our weights initialized as unique numbers? The best way to do this is to randomly grab a bunch of unique numbers, which we can do by sampling from a probability distribution. A good solution for getting these random weights is to sample from a uniform distribution. A uniform distribution has equal probability of picking any number from within a range. We'll be picking values from a continuous distribution, so the chance of picking the exact same number is very low. First, I'll show you what these values might look like by using a helper function that displays a set of random values as a histogram. Here I'm using NumPy's random.uniform function to pick random numbers from a uniform distribution. This function takes in a low and a high bound on the range of random values to generate. And here I'm specifying that it should generate 1,000 random values in a range from -3 to +3. And here's the resulting histogram. A histogram is made of many rectangles whose height is proportional to the frequency of a certain value. In this case, our histogram is actually creating 500 buckets for each of our 1,000 generated values. And for a uniform distribution, we should see that most buckets then contain 2 generated values, which we can see by this line 2 about here. A few buckets have 0, 1, or up to 10 values in them, but this is just a little bit of randomness. In general, we should see that these values are fairly uniformly distributed along this range. By picking the initial weights of a model from a distribution like this, we're incorporating some randomness that should help our model train. And we can still set some constraints on which values our weights take. Now that we've seen a uniform distribution, let's see how well our model trains if it's initialized with uniform weights, where I'll set the low value to be 0 and the high value to be 1. And here I'll show you one other way, besides in our net class code, to initialize the weights of a network. To define weights outside of the model definition, you can define a function that assigns weights by the type of network layer, then apply those weights to an initialized model using model.applyFn, which applies a function to each model layer. So here I'm defining a function weights init uniform. This will be applied to every single module in our model. And here I'm checking for any linear layers in our model. For the weights in each linear layer, I'm going to apply a uniform distribution with a low range of 0 and a high of 1. And here I'm setting the bias to a constant value of 0. Just like nn.init, there are a number of distributions that you can call upon to initialize the weights of a network in this way. Then there's one more step. To actually initialize a model with these weights, I'm going to instantiate a new model. I'm going to call it model uniform, and I'm going to set it equal to a default net. Notice I'm not passing in any constant weight value here. Then to apply my uniform weights, I'm going to call apply weights init uniform on this model. Apply will recursively call my initialization function and apply uniform weights to every linear layer. This will also print out some details about that model. Finally, I'm creating a model list of just length 1, and I want to see how this uniform model performs. Here we can see that the loss still starts out fairly high, but it's decreasing fairly reliably. And after training for 2 epochs, our model gets around 33% accuracy, which is much better than just guessing, so we know that we're on the right track.